Hub. So it's an EU Horizon funded project looking to create an excellence hub for water in the circular economy to support innovative water management solutions for Europe's widening countries. And you can find out a lot more about the project and the upcoming activities on the social media platform, on their Instagram account, Waterwise Hub, and also on the LinkedIn page. I will now hand over to Melissa, who will also introduce herself and today's speakers. Thank you.
Hello, everyone. It is a pleasure to be here with you today to share learnings about the project, ARSINOE project, especially for us, for BGG, which has been one of the implementers. BGG, I'm starting with an introduction of myself and the organization and our role in ARSINOE, and then I'll hand over to our distinguished speakers for today. So BGG is an NGO established in Tirana, Albania. Our focus is circular economy, climate change education, mitigation and adaptation, as well as digitalization and innovation. I have the role of project manager, and I have also been involved in the implementation of ARSINOE project in case study number 4, focused on Ohrid and Prespa Lakes, supported by the National Territory Planning Agency in collaboration with Polytechnic University of Tirana, as well as the Institute of Geosciences. And I'm happy to have witnessed real great impact, such as the integration of sensors for real-time data collection, drone filming, the establishment of the open source platform, as well as stakeholder capacity building. So I'm really also happy to hear from our speakers today on sharing their impact on also on ARSINOE project, and focus on the improving our resilience to water scarcity induced by climate change in the Ohrid and Prespa Lake region. So with no further delays, I would like to invite our distinguished speakers. So Ms. Diana Likar, firstly introduce herself, a short introduction of your background and experience, and then Mr. Roussos to do the same. So can you please introduce yourself and your experience, and then we of course will hand over to the presentation for today.
Thank you, Melissa, for this introduction. My name is Diana Likar from IC North Macedonia. We were the organization leading the project case study. Today, with my colleague Orpheas Roussos, we will present the experience of the project ARSINOE in improving resilience to water scarcity induced by climate changes in Ohrid and Prespa Lakes. NECA was a contributing partner along with AKPT, Albanian partner. Later you will hear from Orpheas himself about the experience of collaboration. I think that introduction about project related experience would be sufficient for the sake of time to leave more for the presentation of the topic. Unless Orpheas, if you would like to say something about yourselves, or you would prefer to start the presentation.
Just that I'm Orpheas Roussos, ARSINOE external associate for NECA, and that NECA is a natural environment and climate change agency in Greece, which is responsible for all the protected areas in Greece. So it was, let's say, natural that we were the Greek partner in this case study. That's all.
Thank you. I hope you can see the screen. Yeah. So we are presenting on the ARSINOE experience in coping with water scarcity in the region. we will have two sessions, presenting sessions. The first one will be about the modeling activities, and the second one, presented by Orpheus, will be about the participatory co-design approach we applied in this international project. First, about the project itself. It was a large project that was financed by Horizon 2020 in the category of innovation action under the Green Deal call. It lasted 4 years, finished last autumn, and was carried out by 42 partner organizations coordinated by the University of Thessaly. The main objective of the project was to support communities and scientists in efficient evaluation of environmental and economic effects of climate change, and to help in understanding of the impact of possible interventions by citizens and scientists or multidisciplinary studies by applying collaborative design through living labs. The project was concept proved in 9 case studies across Europe, and the case study that is subject of today's presentations are Ohrid and Prespa Lakes in the Western Balkans. So you see the wide span of coverage of the case studies from Athens metropolitan area through Mediterranean ports, region of Main River in Germany, Canary Islands, Black Sea, countries sharing Black Sea, southern Denmark and Torbe and Devon County with flooding problems, and Mediterranean islands, Sardinia as a Mediterranean main food producer. They all coped with water scarcity along with the citizens in the regions. In Ohrid and Prespa Lakes, we performed water scarcity, dealing with water scarcity induced by climate changes by applying 2 parallel approaches, the modeling one and system innovation approach or participatory approach. In this session, we are presenting how we have established climate vulnerability and how we have set basis for adaptation strategies by an overview of modeling activities, results, and findings therefrom. About the region itself. It is situated in the Western Balkans, and it is among the region with the oldest lakes in Europe, tectonic lakes, over 2 million years old. They form a natural hydraulic phenomena of one lake discharging through groundwaters to the other one. Prespa is discharging groundwaters to Ohrid Lake below the mountain of Galičica that divides them. The watershed areas of the 2 lakes are presented with blue line for Prespa and yellow line for Ohrid Lake. The red lines are boundaries, and the countries sharing these water bodies are Greece, North Macedonia, and Albania. This area is within the most ecologically significant aquatic ecosystems in Europe, renowned for exceptional biodiversity and endemic species, and also recognized as a UNESCO protected heritage area. The photos on the slide present the current situation of the lakes. Prespa Lakes is very dried out at almost historically minimum level, while Ohrid Lake is still at good status because the discharge therefrom towards the Drin River going to Albania is artificially maintained at the same level in order to preserve valuable ecosystem in the watershed. The key challenges we faced as a project team were water scarcity evidently escalating and becoming a rising trend in the region. Then sectors of environment, society, and economy have been jeopardized in their survival and development. Climate change pressures and at the same time growing demand arising from the demographic shifts and economy changes induce competing demands, competing consumption patterns among the sectors, and that requires a complex way of coping. Most effective way of response to this challenge that we have found is to deploy comprehensive and integrated analytical and implementation approaches to correct and fair identification of water issues, enabling decision-making and include all affected sectors in creation of consensual adaptation solutions. The main objectives the case study had was to improve climate resilience of all sectors, including sectors, by providing an intelligent, innovative set of long-term planning solutions. Key systems that we addressed included environment in form of biodiversity ecosystems, society in form of citizens, households, water management utilities, policy-making bodies, economy, agriculture, fishery, tourism, industry, and hydropower sector as economy sectors traditionally present in the region. The methods we have applied included innovative solutions being previously developed to be tested and implemented because it was an innovation action project. We applied integrated water management model as a simulation and optimization model to evaluate a complex hydro system long-term operation under superposed climate and socioeconomic scenarios. This model integrates hydrological processes, climate changes, and use of water in coupled sectors at a hydrological unit scale. And the results that it provides can be categorized into groups: suggested allocation of water per sectors and recommended optimized adaptation options related to water scarcity. The climate modeling started with the first step of selection of relevant climate scenarios. In the first half of the project, we used the ultimate climate scenarios of RCP 2.6 and RCP 8.5 as the most optimistic and most pessimistic scenario, leading to corresponding to the global warming of averagely 1.5 degrees by Celsius at the end of the century and 8.5 degrees Celsius respectively for the two scenarios of RCP 2.6 and 8.5. We downscaled the regional climate models of Series 5 and coupled them with accompanied SSP sectors, SSP projections of SSP 1 and SSP 5. We made time projections 80 years ahead from 2020 to the end of the century with a milestone of 2050 of the selected representative climate change indicators in form of mean monthly sum of precipitations and mean monthly air temperature. We covered especially the whole watershed areas of Ohrid and Prespa Lakes in all the three countries, and we treated them as separate watersheds because of their different physical performance and operation. We used measured data for 40 and 60 years before the projecting horizon, meaning 2060 to 2020, for measured temperatures and precipitations in meteorological stations in the two countries, Macedonia, North Macedonia and Albania, while data from Greece were available on the website of the corresponding Ministry of Charge of Waters and Environment. In the first half of the project, we applied multimodal ensembles approach to find out to come to the projections of precipitations and temperatures. And we compared the ensembles of approximately 20 downscaled regional climate models with the measured data, which on the slides are presented with the blue line. So blue curve is actually the measured data, while on the right-hand side of each of the figures, we can see the simulations that we downscaled in form of regional climate models for this part of the territory from the Cortex database, with a middle red line presenting the trend, the average of the ensemble. Conducted by this, we filtered the ensemble in two steps iteratively to exclude those models that made distraction from the trend line and can be a cause for a bias that is over the limits that are recommended for this type of projections. Excluding the disturbing models from the ensemble, we come to the projections of the temperatures from 2020 until the end of the century. Again, the blue line are the measured data for the annual temperature in Prespa for the two scenarios. We see that in the mild scenario 2.6, we will have only 1.5 degree of the average temperature raise. And for the 8.5, we will have a very huge temperature range, very exhibited. Excuse me for a moment. The same exercise was carried out for the annual precipitation, and we have received the annual precipitation. Just a moment. Sorry. For the annual precipitation, downscaled ensembles and filtered thereafter. I'm sorry for this. We received that precipitation will receive almost the same trend with very small declination by the end of the century in the scenario 2.6, while in the 8.5 we will receive, we can expect projection of very low precipitation. When put into the mathematical model of the watershed, precipitations and temperatures included in the evaporation and evapotranspiration module give projections of the water balance of the watershed, which is in form of change of the available volume of water in the lake when it comes to Prespa Lake water balance, which remains as available with a positive or negative sign, plus or minus, depending on the water accounting equation, at the end of the time sequence observed, month or a year. For the Ohrid Lake, we have a different mathematical representation of the physical processes because of different physical operation of the watershed area. Ohrid Lake actually operates as similar as an artificial reservoir impounded by dam, because we have a regulated discharge at the town of Struga towards the boundary with Albania. Two countries, North Macedonia and Albania, because we maintain almost the same water level in Ohrid Lake for the sake of the environment in the watershed, to preserve ecological systems. As a result of the models run, we receive as a representative output change of water level elevation in Prespa Lake. The blue line again presents the measured data in the past 40 years, while the red line presents the projected data in the next 80 years. For the scenario 2.6, we see expected decrease of the lake, with a possible reach of physical disappearance of the lake by the end of the century, complete dry out, while in the second observed scenario, the most expected warming, corresponding to the most expected warming, we see that end of the lake could happen earlier at 2060 if the trend continues and nothing is taken as an action to prevent this condition. For Ohrid, we have another type of output in form of available volume presented on the slide. We see that for the 2.6 scenario, it will remain the same almost as in the previous 40 years of measured data, while in the scenario 8.5, we will have a strong decrease of the available volume that is discharged from the Ohrid Lake to the river of Drin. And that is a very important finding, at least as our country is concerned, because the discharge from the lake that is represented on the slide at the town of Struga into the Drinov River will cause decrease of the inflow into two artificial reservoirs at two hydropower plants of Globočice and Špilje in North Macedonia, and 3 cascade hydropower plants on the same river in Albania. So to preserve the environmental ecosystems in the watershed of Ohrid Lake, we will have to maintain the water level, and that will decrease the available volume for hydropower generation in case of scenario RCP 8.5. That means that in case of 2.6, we will have almost the same power generation expressed in gigawatt hours. It is almost 120 gigawatt hours annually in the first hydropower plants. While for the scenario 8.5, only 38 gigawatt hours will be produced from in the first hydropower plant will be produced from the discharge of Ohrid Lake. It is almost 22% compared to 67%, which is the current situation or made of previously measured data, previously average data. So almost 1/3 will be available for the next years. In parallel, we run the model of consumption by social and economy sectors. Households presented future water consumption. Blue line represents future consumption in households. Yellow line presents the consumption we expect in industry. Green line is touristic sectors, and red line are losses, which we presume they will be remain the same unless something is taken, losses in network. The projected data of water consumption side are based on downscales data of future population change in the region and economic growth GDP of sectors, which we correlate with the future consumption of water. The decrease of consumption of water in households at the middle of the century actually means that a decrease of the population number is expected according to the downscale data from SSP database, which we explained as the boundaries of the region are such that maximum of the inhabitants can be reached about the middle of the century or about 2060. Thereafter, we can expect decrease of population and accordingly decrease of water consumption. That is, the water demand side has been it has been captured by this module. Results, we have already explained some of them. Both lakes will be affected by the climate changes. We can expect decrease of water level in Prespa Lake and this decrease of available volume to be used in hydropower generation in Ohrid Lake area. The most affected sectors that could be environment, agriculture, and energy sectors. And therefore, we came to a conclusion that adaptation strategy should be developed in the nexus approach. Trade-offs between sectors have been identified in groundwater resources abstraction in Prespa Lake watershed and in between environment and energy at Ohrid Lake watersheds. Transboundary aspects that we have considered are twofold. One fold is that we have old area captured without boundaries, political, geographical boundaries, only hydraulic boundaries of the watersheds that have impact on all countries. Area from all countries is included. Then we provided and treated data on current and previous water consumptions from 6 municipalities from all the 3 countries. And socioeconomic projections were downscaled for the 3 countries. The other aspect of participatory approach will be captured in the second session of today's presentations. Major finding was that the conditions of the lake will be endangered, but due to climate changes, we couldn't find any activities that could contribute to the lake's endangering status, because the water consumption currently is only 1% of the total water balance amount. The major water loss in our water that occurs in our water balance calculations is due to evapotranspiration from the water lakes surfaces. It is in the range of 100 million of cubic meters of water annually lost because of temperatures, and it will increase due to temperature rise. So there are no transboundary issues, no economic activities that neither of the country undertakes to endanger water status. The problem is transferred to sectoral level. So the other important conclusions that come out from the modeling activities is that aspect should be of the aspect of strategic response of building resilience of the region should be not on mitigation, adaptation rather than mitigation. And in this direction, we needed to profile the adaptation actions. When identifying adaptation actions to be taken, we listen to the outputs we have received from transboundary and national workshops of the system innovation approach. We identified 4 groups that stakeholders had seen as a pathway towards resilience. Group 1 of improved measurement and monitoring of water resources, especially of groundwater. Group 2, improved measurement and monitoring of water consumption. Group 3, improved and innovative technologies for effective water use in sectors. And Group 4, improving capacity, raising awareness, skills for water use in sectors. What we have mentioned previously in the presentation, the hydropower sector, which we expect to be endangered in further years if the mild or severe climate scenario occurs. Adaptation strategy for these sectors include measures that are not affecting other sectors. Therefore, we decided to run these measures to test them within another study and research field. We ranked the adaptation measures again using criteria that the stakeholders identified as future vision of the region in the innovation pathway matrix. And the criteria that we used were the following: climate resilience of the adaptation action, meaning how that adaptation action leads to improved sectors' independence of fresh water, how it improves reduced consumption of fresh water. Then criteria of cost effectiveness, which sets grounds to increase investments in climate resilience. Criteria of environmental positive impacts, more water available for biosystems, social and economic progress, an area of coverage of the measures, how this measure can affect sectors and systems. The results of ranking shows that measures covering monitoring of water, improved monitoring and available data takes the first place. The second ranked is group of measures for more efficient and rational water use, then measures for improved measurement of consumption, and measures for raising awareness as last rank, because we found a significant level of awareness and commitment of stakeholders from all sectors from the 3 countries. We included circular economy of water as one of the advanced measures, measures that can improve fresh water reduced consumption. We tested that, we simulated that in 2 sectors, in one of the municipalities. In sector of tourism, we simulated 30% of the water consumed by this sector to be replaced, to be recycled and reused. In the 2 scenarios of development of the sector, SSP1 and SSP5, with dashed line, we present the reduced consumption, and we can see that it is a significant amount of fresh water that can be used if the sector tourism is equipped in the future to recycle and reuse or give away the water that it produces as wastewater. In sector industry, we have quite conservative coefficient of recycling of 20%. That is because we try to align that with the narrative we have received for the scenarios, future vision of the region, in which stakeholders see the region as industrially developed, but occupied with industry which are less resource demanding and less resource consuming and disposing. So with 20% of recycling of water in industry, we will receive reduced consumption of fresh water, represented as dashed line for the two scenarios of development, SS5, more intensively, industrially intensively, and SSP1 as more mild scenario. The conclusion of this session is that integrated modeling approaches, system models, when leveraged by engagement of community, can provide very efficient, long-term, reliable, balanced, and coordinated adaptiveness strategy. And that availability of information and data on resources status enhances awareness and actions towards resilience. This is the end of session 1. Thank you for listening carefully. And at this moment, I would like to ask my colleague, Orpheas, to continue with the presentation of session 1. If you agree, we can leave the questions and answers for the end of presentation. Okay, thank you.
So you can see my presentations, okay? In this second session, we'll focus more on the transboundary relevance of the case study and mainly on the process of collaboration and co-creation, the participatory approach. So, what were the main challenges we faced in transboundary water management in the Prespa Ohrid watershed? One is that obviously the watershed is shared by 3 different states, one of which, Greece, is a member of the EU, whereas the other 2, North Macedonia and Albania, are still in accession process. And this means that there is a different status in the environmental legislation and the water management legislation. So, for example, the Water Framework Directive or the Habitats Directive are in force since many decades in Greece, while Albania and North Macedonia had their own systems which are now being adjusted to the EU legislation. Also, another point is that we have 3 different languages. Not everybody is fluent in English. And this is especially true for the local stakeholders, who are the ones who are actually critical for the implementation of the environmental legislation and the water management. Additionally to that, we have to deal with different political and economic traditions due to Cold War. We have to keep in mind that during this period of 50 years, the 3 countries belong to 3 different global alliances. Greece in the Western camp, Albania in the Eastern camp, and Yugoslavia was in the non-aligned movement, which the result was for such a long period, we didn't have almost no cooperation or coordination. Adding to that, there is a different focus by each country regarding Prespa Ohrid watershed due to geographical reasons. For Greece, it's a relatively small and remote part of the country with little economic interest, which makes it possible to put more focus, let's say, on biodiversity protection or environmental protection. On the other hand, in North Macedonia, it's a very significant part of the country, also very significant for tourism. And both for Albania and North Macedonia, as we've also seen in the previous presentation, it's very important for energy generation, which is an issue of no concern in Greece. Also, we have to keep in mind that now there are some transboundary institutions already in place, such as Prespa Park Management Committee, which also includes a working group on water management. Every action needs to be aligned with them. And also there are differing levels and forms of local participation across the three countries due to different kind of skills, social and sectoral backgrounds. There is also a series of many involved institutions which do important work. And so we have to coordinate all this. Adding to all that, there is a complex transboundary status of protection in the Prespa Ohrid watershed. All the three lakes, Ohrid, Greater Prespa, and Lesser Prespa, are wetlands of international importance according to the Ramsar Convention. But there is, for example, the Ohrid Prespa Transboundary Biosphere Reserve. You can see it here in the cyan line, which is only in Albania and North Macedonia. The Lake Ohrid is declared as a UNESCO Monument of Cultural Heritage. There is also the Transboundary Prespa Park, which is the first transboundary environmentally protected area in Balkans. You can see it here in the yellow line. And there are also different areas protected at national level, which you can see with the green shading. So there are many overlaps, let's say. But you have the reality that measures that apply in only one country or only one lake can only have limited effects in water management, since all three lakes are connected to each other, both through surface and underground connections. So how we dealt with this issue in ARSINOE, with all these issues. The methodology we used was the system innovation approach, which is an analytic approach towards systemic change based on an interconnected set of innovations. It is being applied for solving complex problems with many parameters, laying the emphasis on the functions of the cross-sectoral system as a whole and on the variety of actors, instead of just focusing on specific functions or individual or sectoral benefits. And the tool that we used were the living labs, with which we brought together a group of key stakeholders to explore a focal issue. In our case, this was water scarcity. How these living labs were structured. We had 3 preparatory working groups at national level, so 3 in each country, 3 times 3. These were preferably physical meetings, completed with some online groups. Each meeting had about 8 to 15 participants, and following each round of national working groups, there was also a corresponding transboundary living lab. The national working groups were carried out in local language. This was very important to enable the involvement of a wider group of stakeholders. The transboundary living labs were, some of them were online meetings, one of them was a physical meeting. They involved about 25 to 30 participants. There, the results of the national working groups were presented and discussed in an international context. We try to provide interpretation both in online and physical ones, so to make the participation of stakeholders possible who are not fluent in English. In one case, we had a common introduction in English, which was followed by breakout rooms in local languages. Each of these workshop rounds had a different subject. The first one was to map the problem and set the objectives, which had as an output the mental maps and the common problem statement. Building on that, in the second round, we had we confirmed the problem statement, and we also created a common vision for how we would like the ideal future to be in the Prespa Ohrid watershed. And based on that, in the third and final round, we had backcasting and innovations, which were, let's say, we outlined innovation pathways which could be used to reach this ideal future. Now, just quickly, some of the outcomes we had. This is the mental map coming out from the Greek National Working Group. You can see we placed the lake water, the decrease in lake water quantity and water quality in the center, and then how this is interconnected to the various sectors such as agriculture, tourism, biodiversity, and how all these different sectors are also interconnected to each other and they influence each other. This is the mental map of in the North Macedonia Working Group. You can see here they placed more, they laid more emphasis in the models and the simulations, the role that this can play. This is the Albanian mental map. Here they had more emphasis on the deficiencies, let's say, which we are faced with today. And all these three mental maps were joined in a common transboundary mental map. Again, with decrease in lake water quantity and quality in the center, and all the various sectors, how they are connected to it and how they are connected to each other. The result was this common problem statement that the integration of climate adaptive actions by individual sectors, the symbiotic attitude towards use of water among sectors, the improved water measurement and monitoring, all three are preconditions for an effective water management in the long term. In other words, to make it more to make it clear what the problem is that we have fragmented strategies and plans through sectors, with the result that there is an inefficient use of water, there are dangers for the ecosystems, and there is a lack of measurement and monitoring of water quantity and quality. Building on that, in the next workshop, we had three different national future narratives, let's say. These were joined together in the Transboundary Living Club to form a common vision of how we would ideally want the Ohrid Prespa Lakes to be in 2050. It's quite a long text. I just have some excerpts here from the transboundary common vision that through scientific research and collaboration, we reach a good understanding of the connection between the three lakes. And this leads to a reversing of the trend of decreasing water level in Greater Prespa and improved water quality in all lakes. The agricultural production is adapted to climate change through diversification or improved irrigation efficiency. Tourism is developed in a sustainable way, paying attention to the carrying capacity for visitors, and also taking advantages of synergies with other sectors. And there's a regular and permanent water monitoring for ensuring water quality and quantity. The final stage that is that we try to create the innovation pathways for reaching this common vision. We did this by creating 3 separate innovation funnels in each national working group. And then in the Transboundary Living Lab, we joined these 3 together to form a common innovation funnel, which you can see in the picture on the right. How we do this? We started with this common vision in 2050, and then we went backwards. First defining what would be, let's say, the milestones that are needed to reach this vision, first in 2045, then 2040, and goes on. The milestones are the red stickers you can see there. And to each of these milestones, we attached the innovations that are needed to achieve each milestone. These are the yellow stickers. And in some of them, we also attached the institutions that could have the green stickers. And then we transformed this funnel to a table. You can see here just a small part of this table. It's much bigger. The columns with the bold letters are the milestones to be achieved in each year. And on the left of each milestone, we have the innovations that could be used to reach this milestone. So taking as an example, the first milestone we have here for 2025. It was to identify the causes for the water drop in Greater Prespa. And as an innovation that could help to reach this was the real-time real-time measurement of the groundwater level, which could be used to predict the lake water level. This is actually innovation that has been applied during the ARSINOE project. And for each of these innovations, the most important ones, the more feasible ones, we also try to define which are the possible barriers and enabling conditions in the political, economic, social, technological, legal, environmental fields. This is why it's called spatial analysis. So, for example, for this real-time measurement of groundwater level, the fact that there is an existing transboundary structure in Prespa could be seen as an enabling condition in the political field. On the other hand, a possible social barrier is that there could be distrust in the validity of water level predictions from local society if this means that the water abstraction will need to be restricted. This is also a much bigger text. This personal analysis is just a small part of it. So coming to what we learned from all this procedure, I will leave the last 3 because they were already mentioned by Diana. Just the first 2. It was the implementation of national workshops under a common coordination can contribute to the identification of differences in the neighboring countries, but it's not enough in itself to bridge the gaps. It is also important to bring the stakeholders from all 3 countries together in order to reach a common understanding. There are limitations to this. So, for example, the stakeholders who were not fluent in English, they couldn't participate in the transboundary living labs at the same level. even with the presence of interpreters. They didn't feel comfortable enough in some cases. But the fact that we did have the preceding national workshops meant that we did give them the chance to express their views in an environment in which they felt more comfortable. And we gave them the opportunity to interact with stakeholders which operate at the regional or national level, thus overcome the difficulties of geographic isolation and accessibility. So that's all from my side. If you have any questions, or to me or Diana.
Thank you, Diana and Orfeas, for your presentations and valuable insights. As already mentioned, we would like you to have some, so we are giving the floor to you for questions, and of course that our speakers will be happy to provide answers accordingly. We do not have any comments yet in the chat.
Yeah, if you want to, there we go. Okay, we have a question or a hand up. Yeah, go for it.
Hi, I'm Thalia Grigoriadou, and Orfeas is the valuable actual external colleague managing this ARSINOE work on behalf of NECA and supporting our Department of Climate Change. So I wouldn't like to take the time for someone having question. If I would like just to mention something at the end of this really enlightening webinar. So in case there is a question, I can wait for that mentioning.
Do we have any questions from the chat? Otherwise, I do have a question. But if not, if no one in the chat has a question, I'll quickly ask mine if that's okay, and then please carry on. So ARSINOE is now finished. Where do you see the next steps for the work that you've been doing for the project?
Question about ARSINOE. What do we say next steps?
Yeah, so where the work you have been doing for ARSINOE is now finished, what do you think will be the next steps for the region?
Yes, for the region. Firstly, the community that participated in the living labs, what Orfeas has presented, is a valuable asset, and we will try. Project partners will continue their collaboration in engagement of that community in monitoring. Let's not forget that as a result of the two parallel processes, the modeling process and the participatory process, the same outcome was produced. And these are two innovations piloted in the regions of Prespa, in the Albanian and North Macedonian demarcation, and they are all they're complementary. They're measuring stations that provide real-time data information and are available for community, for researchers, citizens, on groundwater level and on water quality level. So we already have assets on which we will build. On the modeling part, we will try to connect to the real-time data on the measured values of water, quantity and quality, and on the feedback, because the innovative solutions that have physical demonstrations that we have implemented actually engage community in providing responses. They see the water levels and they can respond, they can alert, they can comment via websites. So this engagement of community and upgrading of the model to be alive, to be a potential cornerstone of a digital twin of the watershed would be for the direction, of course, with collaboration of the partners from NECA Greece and AKPT Albania. Orfeas, would you like in Italian to amend to this, where you see future perspectives?
Just to mention one additional aspect, let's say that at least in Greece, we also have our local unit there in Prespa, which has a usual and direct contact to the stakeholders involved. So this will make it easier for them also to make use of the ARSINOE results.
Just can Talia add? Talia?
Yes, actually, Diana and the addition of Orpheus, you have mostly covered what I wanted to express a bit earlier. Thank you, Penny, also for giving me the floor. At first, I would like to thank you for your interest in our work, and thank you very much also for your kind invitation to participate, and for Diana for organizing all this along with Penny. And for me, aside from these very important innovations that were produced and implemented that Diana has referred to, at NECA, and I believe it's an all partners wish. We hope that this work of ARSINOE and this Living Labs implementation of the SIA methodology. I'm sorry I have my camera turned off, but I have a really bad sound connection. That's why I'm keeping it that way. So we sincerely hope that this work will have an impact on the way, actually, in the ways that people at the region of Prespa and Ohrid Lakes will work and collaborate. This all-engaging way, it's the participatory collaborative design, as Diana and Orpheus presented earlier, that engages locality, the public, the all sectors professionals, and experts and policymakers at the same time. Actually, I think of it as an approach that supports at the same time the horizontal, let's say, transboundary dialogue between the engaged countries, and at the same time it supports each country's, let's say, bottom-up evaluation, assessment of challenges, and all these results in a more efficient water management. So these were my thoughts, and again, thank you very much for letting us participate in this very enlightening webinar.
No, thank you all to our presentations.
No need for thanks, Talia and Orpheus. You were a valuable member of the team, along with Nancy Lalai from AKPT. She is now working in other agency. That's why she's not in the presenting team, but the contribution remains and legacy remains, and we have intention. Just to mention that transboundary waters are very sensitive area. Water itself is a valuable resource, and even it is shared by 2 or more, 3 countries, it is very important to take into account all possible measures. Circular economy of water, what is the subject of objective of water-wise excellence labs, has been accounted and it was ranked very highly as second effective measure in the region. So we will probably apply some of water-wise hub outputs in the countries as well in continuity.
Anyway, I will now be closing the session, but thank you so much to our speakers. I really enjoyed the talk. I have put my email in the chat, so if anyone does think of anything later on in the day and they want to send in a question, please send me an email and I will forward it on to our speakers. We will be doing, if someone's not on mute, could they just quickly mute their microphone? Thank you. As I said, this is the end of the spring series of the webinar, Water-wise Hub webinars. We will be doing a summer one, which will be starting in May, and we have some excellent talks coming up. So it'd be lovely if everyone can attend those as well. But for now, I will say thank you very much to our speakers again, and thank you for attending, and I will see you all shortly. Okay, thank you. Goodbye.
Bye.